instructions, and then you also have a review sheet. And you need to have both to turn in. There is a piece on disseminated intravascular coagulation, which is a thing that can happen in association with preeclampsia. It's pertinent to obstetrics. There is a biography on Judith Graham Poole, who was one of the researchers who did some of the work on blood coagulation and hemophilia. There's a piece on blood disorders overall, and how they relate to each other. There is a nice little piece on sickle cell anemia. Blood disorders are not only disorders of not enough, sometimes blood disorders are disorders of too much. So there is a piece on hemochromatosis. Hemochromatosis is something that didn't even get talked about 15 or 20 years ago. Okay? And it's now something that is becoming more understood. And there's some interesting theories about diseases in particular populations in hemochromatosis.
I have a question about that really quick.
Yes.
Is there any way to find out if it's, because I know there's 3 forms of hemochromatosis. Mm-hmm. Is there any way to find out if it's genetic other than doing a genetic screening?
Not that I know of.
Okay, perfect. I know. Yeah.
Okay. Again, just briefly, we won't get into the details here, but it's thought that the reason why American black people have such a higher incidence of sickle cell anemia is because most of the black people in the United States came from equatorial Africa, and it's part of the malaria belt. And sickle cell anemia gives some protection in some forms for malaria. We'll get into the details of that later. With hemochromatosis and with cystic fibrosis, the white population is where you find the highest incidence. So the question has been, well, if there was a disease that was driving the selection of these people in the black population, what disease may have been driving the selection of these in the white population? And the theory is that cystic fibrosis may have protected against cholera and related diseases, and the theory is that hemochromatosis may have been of benefit in surviving the plague. Okay, again, those are theoretical. With sickle cell, it's much more well established because there's been more research done. All right, there's a piece on rhesus isoimmunization, RH disease, okay, which was taken out of the gynecology textbook. But I know that some of you are going to have questions about that at this point. So that's up on ThinkWave as well. Okay, now, blood is a connective tissue. If you remember way back, way back to chapter 4, the connective tissue is something that has cells in a matrix. Something that has cells in a matrix. Blood has cells in a matrix, but in this case, the matrix is liquid. Another difference between blood and other connective tissues, the matrix cells make the matrix in a normal connective tissue. Chondrocytes make cartilage. Bone cells make bone. Okay? Fibroblasts make other types of connective tissue. They make collagen and so forth. By and large, the blood cells don't make the matrix. They don't make plasma. Okay, so red blood cells, for example, don't produce plasma. Okay. So in that respect, blood is much different than the other types of connective tissues. However, functionally, blood is a connective tissue because it connects every part of your body to every other part of your body. Okay. It is a connective tissue because it connects every part of your body to every other part of your body. Okay. It is how your toes, which are so far separated from the digestive system, get nutrition. It's how your toes, which are so far separated from your lungs, get oxygen, okay, and conversely get rid of waste products and so forth. Okay. So the blood is hugely important in running your body. I remember reading an author back when I was in nursing school. When I was in nursing school, the big deal was the cardiovascular system. Okay. And rightfully so, because there's so many people who die from heart disease. But this particular author said, if you want to be healthy, you have to have healthy blood. And I remember thinking, blood? That's just something you test. It's not, what does that have to do with anything? Okay. But when you understand how physiology works, blood actually is a huge big deal. And what we're going to be spending the whole rest of the term talking about is what the different systems do with blood. The cardiovascular system is responsible for getting the blood around. Okay, it helps transport stuff. Okay, the respiratory system is responsible for the gas concentrations of the blood. The digestive system is responsible for providing building blocks and fuel molecules to the blood. Okay. The urinary system is responsible for the fluid concentrations and the particle concentrations in the blood. Okay. The liver is responsible for the clotting factors and the other carrier proteins in the blood. Okay. The immune system is part of the blood and part of several other systems as well. Okay. So it's kind of one of those all trails, if you follow them back, kind of lead back to the blood. So the author was right. If you want to be healthy, you need to have healthy blood. So, what we're going to talk about first here today is the blood plasma, okay, the matrix of the blood. And then we're going to spend the rest of the time talking about the formed elements with the cells that you find in the blood. So, when you look at the blood, were to if you were to take some blood out and stick it in a test tube, and then you were to spin the test tube. When you spin things in a centrifuge, the heaviest things go to the bottom, correct? Okay. So when you spin the blood in a centrifuge, the heavy stuff goes to the bottom. The heavy stuff is the formed elements. Now, the formed elements usually mean cells. So why don't they say cells? They don't say cells because of platelets. Platelets are actually cell fragments. They are considered as part of the formed elements. And we'll get to platelets later on. So the heavy stuff settles out on one end, and that leaves the plasma, or the liquid stuff, on the top. Now, if you look at this, if this is 100% of what you started out with, this part is a little less than half of what you started out with, correct? Mm-hmm. Okay. So your formed elements, okay, make up a little less than half of your blood volume. We call this measurement here the hematocrit. The hematocrit is the amount of formed elements that you have in your blood. And there is a range of hematocrit that is normal. To me, it's easier to remember one number than to remember a whole bunch of numbers. So I just remember that the hematocrit is equal to about 45%. A little bit lower than 45% is going to be okay. A little bit higher than 45% might be okay, depending on the circumstances. Now, that's the textbook definition of a normal hematocrit. My brother is a critical care nurse, or was a critical care nurse. They don't get real excited until the hematocrit gets below 35. Okay? So if you ask him what a normal hematocrit is, he's likely to give you a lower number because he's used to looking at people who've bled out half their blood. Okay? A normal hematocrit is about 45%. Now, that includes red blood cells, white blood cells, and platelets. However, you have far more red blood cells than you do white blood cells or platelets, by far. So you could say that the hematocrit is a rough estimate of how many red blood cells you have. Now, what do you know about red blood cells? Just off the top of your head. They carry oxygen. So your hematocrit is kind of a rough estimation of your oxygen carrying capacity, correct?
Mm-hmm.
Okay. Your hematocrit is a rough estimate of your oxygen carrying capacity. And you need to know that. And you need to know what the normal number is. Now, this picture might be a little easier to see. Let me erase my stuff on here. If you look real close to your column of blood there, you may see a little white layer on top of your red blood cell layer. That little white layer on top, white or cream layer on top of your red blood cell layer is called the buffy coat. It turns out that erythrocytes settle more effectively than white blood cells do. So your red blood cells are going to be down here. Your white blood cells are going to be closer to the top. And in fact, they tend to accumulate in that white layer there. In a normal person, that white layer is either not distinguishable or it's very thin. What if you have a buffy coat that instead of just being down here, comes from down there all the way up to there? Okay. You have too many of white blood cells. What could cause that?
Infection.
Okay, the two leading things are cancer or infection. What we're going to see is that infection does raise the white blood cell count, but not nearly as much as cancer does. And when you have a huge buffy coat like that, like what I've drawn up there, okay, you're looking at cancer. Okay, you're looking at leukemia. Now, you can also have fat and other gunk that you can sometimes see as part of the buffy coat, okay, which is what this thing is advertising. That's fat on top of. That's not white blood cells. That's fat, okay? And that would be, a ridiculous amount of fat. This is an overstatement. What they are selling is stuff to reduce cholesterol. It's a drug advertisement.
Is that common at all? I mean, is that brutal? I mean, I know it's brutal.
This amount is not common at all,
Okay.
but a level of gunk, yeah, that's why they're treating cholesterol and triglycerides and stuff.
I had my blood taken once, and the nurse was like, "Oh my gosh, I was really thin," and because it floated up to the top of it, looked like chicken fat, like floated, it was disgusting. She was like, "What did you eat today?"
It floats to the top.
Yeah,
On
like
top
as
of
soon
the
as she
cloud.
took it, without
That
being
fast.
centrifuge, she was like, "Ugh," yeah, she was grossed out too.
And so, in other words, if you'd have done a triglyceride level on her at that moment, it would have been out the roof. Now, ordinarily, when we do triglyceride levels and cholesterol levels, we do it fasting, okay? So we can see what the background traffic is. Okay? Not when you just binge wings or
Is
pizza.
that so? Does that kind of explain the glucose test they give you when you're pregnant, and then they take your blood to see how your blood reacts to what you just?
Right. That's with glucose tolerance tests. They will do a fasting glucose, and then they will give you a load of glucose, and they will see how effective your body is at clearing that out. Okay. A person with normal glucose metabolism and normal insulin secretion will clear that out within a specific amount of time.
Mhm.
Okay. If your insulin is not working effectively for whatever reason, okay, it's going to take a whole lot longer for that blood sugar to come down.
Mhm.
Okay. So let's look at the other end of our jar of blood there, our tube of blood. Okay. We said that 45% of it, our hematocrit, is our formed elements. Okay. Let's look at the other 55% or so, okay, which is your plasma. Now, the largest component of plasma is exactly what you would guess it to be, water. Okay. You are a water-based life form, not a chicken grease-based life form, no matter how good it smells. Okay. My family teases me to death about Southern fried, so I'm with you. But there are several other things that also you find in that plasma, dissolved in that plasma. You find electrolytes. Okay, now electrolytes are salts like sodium and potassium and chloride and phosphate and calcium. Okay. And they have specific panels. Sometimes they're called a SMAC, sometimes they're called a Chem 6 or a Chem 7. Different labs have different names for it, but there are panels where they measure the electrolytes in your blood. Okay. You also have organic nutrients. You have your building block molecules that are circulating, your fuel molecules that are circulating. So you have glucose that's circulating in your blood. You have fatty acids and you have amino acids that are circulating in your blood. As we have seen, the levels of your glucose and your fatty acids are going to vary depending on when you ate. They're also going to vary depending on what your hormones are doing. If you have a bunch of thyroid hormone circulating, you may have less fatty acids circulating. They may be burned up. If you have more cortisol circulating or more growth hormone circulating, you may have more glucose, more amino acids, more fatty acids circulating. So your organic components or your organic nutrients are going to vary depending on when you ate, and it also is going to vary depending on the rest of your metabolism. Okay. You have organic wastes. Okay. The breakdown product of red blood cells is bilirubin. We're going to talk about more later. The breakdown product of proteins is urea The breakdown product of nucleic acids is uric acid. So urea and uric acid are elevated with high protein consumption, particularly with meat consumption, which usually also bumps up the fatty acid that is circulating as well. Okay. You're also going to have whatever hormones and whatever immune system signals also circulating in that blood. There are cultures that do not eat the blood of animals, okay? And the more we find out about what's being carried in the blood, the better idea that looks, okay? All right, so you have your other solutes, okay, in your water, and then you have plasma proteins. Plasma proteins. Now we're going to see in a couple chapters here that blood vessels leak. I had the understanding when I was first starting out that blood vessels were just like plumbing pipes, and the blood stayed in them until you stuck a needle into a vein. Okay? And that's not true. Blood vessels leak, okay? Especially small blood vessels. So how come all the water in your blood vessels doesn't end up out in your tissue spaces? Sometimes it does, okay? It's called edema. But one of the things that keeps fluids in the vascular system is the particles in the vascular system. Remember, what's the quick and dirty definition of osmosis? Water follows the particles. The particles that remain in the vascular system vary a good deal. However, the albumins stay pretty constant. And the albumin particles are big enough that they can't leak out under normal conditions. So the albumin particles help osmosis to occur, help to pull fluids that have leaked out back into the vascular system. Now, the albumins also, along with the globulins, help to transport things that can't be left to wander around on their own in your body. Okay? We've already seen one example of this with thyroid hormone. Thyroid hormone has a carrier protein called thyroglobulin. Okay? That's a globulin. Okay? There are also albumins that are transport proteins. Okay? Now, another protein-based and fat-based component here is hormones themselves. There are hormones that are proteins that circulate in the blood. You also have immune globulins. Immune globulins. Immune globulins sounds like something that you dress up as on Halloween. Immune globulins, or Igs, are also known as antibodies. Immune globulins, or Igs, are also known as antibodies. So they're in your globulin category. You also have your antibodies. Now, one of the nifty things about blood is if you pour it out on the ground, it clots, which is nice because it helps to keep you from leaking out all over the floor. And that clotting function is under the control of several proteins. Fibrinogen is one of those proteins, and then there's a whole raft of other clotting proteins. These clotting proteins are manufactured by the liver. Clotting proteins are manufactured by the liver. Now, this regulatory proteins here, less than 1%, that almost looks like it's insignificant. It is not insignificant. There are messengers from the immune system and from the endocrine system that circulate in the blood. There are enzymes that circulate in the blood. There are markers for different disease processes that circulate in the blood. I tease about my husband, the engineer, who's also a pilot and who does all of this stuff, and he has 4 or 5 different jobs, which he kind of literally does. One of the things that he's doing right now is some engineering consulting for a company that is trying to find ways to measure these regulatory proteins here, okay? Down on the micro level, okay? Down on where you would only use, what they're looking for is to be able to find about 200 different proteins in a drop of blood. And when you do that, you can follow very accurately disease processes because those proteins are going to change depending on what the disease process is doing. And you also are going to be able to see from day to day how the choices that you make for your health, how they change things day to day. Okay? So it's sort of like an instant feedback. Well, it's not instant, but almost instant feedback. So if you make a New Year's resolution, okay, I'm going to lose weight, okay, that can be a little discouraging because it takes a long time to lose weight. Okay? But if you can see, when you change aspects of your lifestyle, if you can see the immediate response in your blood, then it's a little bit more encouraging. You know, okay, I'm doing something here. Okay? It also makes testing treatments much easier. Okay? So anyway, that's one of the things they're doing. Okay? All right, so plasma proteins, other solutes. Okay? Now, if you take the clotting proteins and the fibrinogen out of your plasma, will the remainder clot? No. Okay. So if you take the formed elements out, you are left with plasma. If you take the clotting elements out, you are now left with sera. You take the clotting elements out, you're now left with serum is singular and sera is plural. Now, serology refers to looking at blood sera but most of the time when they are looking at blood sera, they're looking at antibodies. Why do I mention this? Because when we get to micro and they start talking about how you diagnose different diseases, over and over and over again they say this is diagnosed serologically. What does that mean? They're looking for antibodies in the serum. That's what that means. So serology, it can include other things, but usually what they're talking about is they're looking for antibodies to some disease. Okay.
You know what else is really cool about plasma? It has, when you're pregnant, it has free-flowing DNA cells of the baby. They just discovered this, and so that's how they're able to find the sex of the baby by taking the mother's blood. And now for women who are O negative, they're or just negative in general, they're able to tell the baby's blood type to determine if the baby is positive or negative to administer Romeo.
Yeah, I had not heard that, but that is
It's very
huge.
new. It's very new.
That is
They
huge.
also don't go away. I read that too. It doesn't. It's in your system forever. That's how you're so connected to your children.
Oh, I didn't know that.
All right, now the formed elements. Okay, white blood cells. There are a bunch of these: neutrophils, eosinophils, basophils, lymphocytes, monocytes. We're going to be talking about all those in detail. Platelets. The old term for platelet is thrombocyte. Now, you know that the ending site there means cells. Okay. Thrombo means clot. So cells that cause clotting. So why don't they call them thrombocytes anymore? Well, sometimes they do, but they moved on to calling them platelets because thrombocytes are not complete cells. They are cell fragments. Okay? But they are pretty sophisticated little cell fragments. So we're going to talk about them down
So,
the road.
thrombocyte clotting cell fragments.
Yeah, they're platelets. Platelets. Okay, and then you have your red blood cells, which are the major component. Your red blood cells, which are your major component. Okay. So, moving on here to your formed elements. Red blood cells are also called erythrocytes. What? I tell you what, it's about time. Let's just take a break. Okay. This is actually a good place to break.